Hey everyone, and welcome. Today we're going to dive deep into the incredible world of plants. I mean, we see them everywhere, right? But have you ever really stopped to wonder how they got there? Well, we're about to uncover the secret evolutionary superpower that let them absolutely conquer the entire globe. So, this is the big mystery we're tackling. How can a giant sequoia tree thrive in a pretty dry forest while a delicate little moss has to have constant moisture just to survive? The answer, it turns out, lies in this huge difference that basically splits the entire plant kingdom right down the middle. Okay, so let's get into the nitty-gritty of this planetary takeover. To really understand how one group of plants came to dominate, first we need to look at the two basic strategies they used to survive. You've got the world conquerors, and then you have the ancient pioneers who kind of stuck to their roots. And here they are, the champions. It's kind of wild when you think about it, but the vast majority of plants you see every single day, the grass on your lawn, the apple you're eating, the flowers in a garden, they all belong to one massive, super successful group. They are all what we call vascular plants. And that one word, that's the key to everything.
So what on earth does vascular even mean? Well, think of it like the plumbing system in your house. Vascular plants have this really sophisticated network of internal pipes that can pull water up from the roots and send sugars down from the leaves. This system is a complete and total game changer.
And this chart just lays it out perfectly. On the left, you've got vascular plants with their internal plumbing, which lets them grow tall, strong, and live pretty much anywhere. But on the right, you have the non-vascular plants, like mosses. No plumbing, they have to absorb water directly, kind of like a sponge, which means they've got to stay small and stick to damp places. To really see this difference in action, let's zoom in on a classic rivalry you'd see on the forest floor, the big, ambitious fern versus the humble, tiny Fernaria moss.
They're often living in similar spots in the forest, so what's with the huge size difference? I mean, one is a lush, leafy giant compared to its tiny neighbor. What gives the fern such a massive advantage?
And the answer? It all comes back to that internal plumbing. The fern is a vascular plant. Its tissues act like both a transport system and a skeleton, letting it grow tall and really reach for that precious sunlight. The moss, on the other hand, since it's non-vascular, it has no support system. It's kind of destined to live life in the slow lane, right on the forest floor, forever in the shadow of its taller competition.
Now, this fundamental split between plants doesn't just decide winners and losers in the forest. This incredible diversity, which is a direct result of these two strategies, it also directly impacts our lives in just countless ways, from the very air we breathe to the medicines we use.
I mean, just take two common vascular plants, mint and chamomile. Their complex internal systems don't just move water around. They also create all these unique chemical compounds that we rely on. One might help settle your stomach, while the other helps you relax and unwind. It's just a little glimpse into the complex chemistry their advanced structures let them produce.
Okay, so we've seen how their structure helps them grow, but what about making new plants? The more modern plants we just talked about use flowers and seeds, but our ancient buddies, the fern and the moss, they have a much simpler, much older method.
They use spores. You can think of them as these tiny, really durable little packages of life. They're incredibly lightweight, which lets them travel on the wind to find a new, damp place to call home and start the next generation. It's a strategy that has worked for literally hundreds of millions of years.
All right, we've looked at the plumbing, the competition, the reproduction. We have all the pieces of the puzzle now. It's time to put them all together and finally solve our central mystery.
So let's go back to our big question one last time. Why the massive difference in where plants can live and thrive? Well, the answer can be broken down into three totally revolutionary steps. Step 1. Develop internal plumbing. This lets you move water efficiently from the ground all the way up to your tippy-top leaves. Step 2. This plumbing also acts like a skeleton, giving you the strength to grow tall and win the race for sunlight. And Step 3. Once you can reliably get water, you are no longer tied to the swamp. You can break free and conquer the entire land.
So the crucial point is this, that internal network of pipes, the vascular system, that was the single greatest innovation in the history of plants. It was the evolutionary superpower that unlocked the potential for plants to grow big, grow strong, and colonize every single corner of our world. It's just a powerful reminder of how one single adaptation can change absolutely everything. Which leaves us with a final thought. As our planet continues to change, what will be the next evolutionary superpower that plants develop to survive and thrive? Thank you for watching.